I'm going to do a few of the problems from this writing chemical equations practice as you guys requested. I am going to do problems 1, 2, and 3, and then 4 and 5 and 6 are all really similar to one of those. So, starting with number 1, aluminum and oxygen gas combine to form aluminum oxide. So the first thing in this problem is that I have aluminum, which is just one type of element, and then I have oxygen gas, which is again one type of element. And for those two in that problem, you can see obviously I told you what the formula would be. The third chemical that I have is aluminum oxide, which has two elements in it. So that's clearly going to be something that I have to write a formula for a compound. So starting with what I have, it says I have aluminum, which is a metal, which is why, since it's a metal, it's a singular Al atom by itself. And, so plus, oxygen gas. So oxygen is a metal. It's on the right side of the periodic table. Oops. And if I didn't know, or if I wasn't given the formula, I would look and it would be one of those special nonmetals that forms the diatomic version. Oxygen is always O2. So aluminum and oxygen gas combine to form, so this is telling me I'm going to have a product now, aluminum oxide. So aluminum is the Al, the oxide is the O. Since I have a metal and a nonmetal, this is an ionic compound. And another clue to that also is that there's no prefixes in front of aluminum or in front of oxide either. So those are two ways that I know this is an ionic compound. So what I need to do if it's an ionic compound is that I need to determine what the charge of each of these elements is. So looking at aluminum, if I find aluminum on my periodic table, it's in group 13, which means it has a charge of +3. Oxide is oxygen, and it's in group 16 on my periodic table. So it's going to have a charge of -2. So I know from ionic bonding that when I have a +3 and a -2 charge together, I need the rule of zero charge to work. So I'm going to need another +3 ion, and I'm going to need two more -2 ions, so that I'll have 2 Als and 3 Os. So the formula would be Al2, because I have 2 of them. 1, 2, right here. And then O3, because I have 3 of them, right? 1, 2, and 3. Okay, so now I've written my equation, and as I said before, you guys can check the answers at the bottom here with those. So I would go down the bottom, and here it is, which is correct. But then I need to balance it. So now I would come back up here, and I need to do my atom inventory. So I need, change colors here so you can see better. I need aluminum. Right now I have 1 aluminum on the left. I need oxygen. Right now I have 2 oxygens on the left. On the right side, right now I have 2 aluminums and I have 3 oxygens. So I'm going to start by balancing the oxygens first, because I can see I have a 2 and I have a 3. So I'm going to have to do a little manipulation with those to make that work. Their least common multiple is 6, right? So I can start by, how do I get 6 oxygens? On the right side, to get 6 oxygens, I would need 2 of the molecule. So 2 Al2O3s. That also makes 4 Als. And then on the left side, in order for me to get 6, I would need to take 3 of the O2s. So 3 times 2, right? so my oxygens are balanced, 6 on the left and 6 on the right. I need 4 Als on the left to make this work. And since Al is singular, I just need to put a 4 in front. So 4 Als, 3 times 2, 3 O2s, that gives me 6 on the left. And then on the right side, I have 2 Al2s for 4 Als, and 2 O3 gives me 6. So 2 of the whole molecule, Al2O3 is how I write that. For number 2, sodium hydroxide decomposes into sodium oxide and water. So again, start with, what are my compounds that I have? And I have sodium hydroxide. So I have one thing to start with, and then that is decomposing into. Decomposing means to break down, right? So that means I'm starting with one compound, and it's going to break down into 2 other things, sodium oxide and water. So water, I know the formula of. Hopefully you guys know the formula of water, CH2O. Sodium hydroxide, I can figure out. That's a 2, there's 2, again, ions, because there's no prefix there. Sodium oxide as well, there's 2 ions, because again, there's no prefixes. So both of these are ionic compounds. So now I need to figure out what is sodium, what is hydroxide. How is hydroxide different from oxide? Hydroxide is one of those special polyatomic ions. Sodium, of course, is Na. Hydroxide is a special polyatomic ion made of oxygen and hydrogen. So that would be one I would look up on my special polyatomic list. Sodium, as we know, being in group 1, has a charge of +1. Hydroxide, from looking it up on my polyatomic list, has a charge of -1. So that means that these 2 together already have a 0 charge for the compound, so I don't need to do anything else with that. Sodium hydroxide now is going to decompose or break down into 2 things. Sodium, which again, Na, and then oxide is oxygen, right? Just change the ending to "ide." So NaO, but to write the formula, I need to look at the charges of those. Sodium is a +1 charge again. Oxygen, being in group 16, is a -2 charge. So oxygen and sodium, just with one of each of them, does not make a compound with 0 charge. I need an extra oxygen to make that work. So I'm going to need Na2O, because +1 + 1 - 2 would add up to 0. And then the third thing that I have, of course, is water, which is just H2O. So I have a written equation. Now I have to balance it. So again, create my atom inventory. I have Na, I have 1 on the left side, I have O, and I have 1 on the left side of that, and then I have H, and I have 1 on the left side of that as well. On the right side, I have Na2O, so I have 2 Nas. I have oxygen here, and I also have oxygen here, so I have 2 of those right now. So that's a 2. And then I have H2 in my H2O. So I have 2, 2, and 2. So this is pretty easy to balance, because all I need to do is I just need 2 of everything on the left. Since I only have 1 compound on the left, then I just need a big old 2 in front of NaOH, which makes that 2 Nas, 2 O's, and 2 H's, because 2 times that whole thing, NaOH, is what I just did. So now I'm balanced. Okay. Third problem. Silver 1 carbonate. Again, it's decomposing, so that means we have silver 1 carbonate, and that's going to break down. Decomposes to form silver metal, carbon dioxide, and oxygen gas. So 3 products. Okay, so I'm going to start with silver carbonate. That's, again, something that does not have prefixes, and it does have a metal in it, so that tells me it can't be covalent. It has to be an ionic compound. So silver is Ag. Silver 1, the Roman numeral 1, remember, means that that has a charge of +1. So that Roman numeral tells us the charge. The other thing I have here, carbonate, does not have an "ide" ending. So anytime you have an ionic compound that does not have an "ide" ending, that's always, always, always got to be a clue to you. Oh, it's one of those special ones. I need to look that up on my polyatomic ions list. So carbonate is CO3. And if we look it up, it has a -2 charge. So again, this together doesn't balance out exactly, doesn't equal 0 charge. I would need another silver ion to make that happen. That would give me +1 +1, -2 to make a compound with 0 charge. Okay, so silver carbonate is decomposing or breaking down to form 3 things. First of all, silver metal. Since it's a metal, it's just going to be singular all by itself, so just Ag. Second thing is carbon dioxide. So here we have a prefix, di, and di means 2. So this is a covalent compound because carbon and oxygen are both, oxide is oxygen, those are both nonmetals, so this is a covalent compound, and that prefix also is a clue that it's covalent. So carbon is just C, and because there's no prefix there, that means there's just one of them. So C. Dioxide means there's 2 oxygens, so we write that as CO2, which is something most of you guys are probably familiar with anyway. You know what carbon dioxide usually is. And then finally, our third compound is oxygen gas, which is a nonmetal, and it's one of those that forms this diatomic molecule of oxygen, O2. So oxygen gas, if oxygen is an element by itself, it's always O2. And the same with those other ones from the list, from the slideshow from the other day. So now I'm ready to balance. Okay, so I have Ag, I have C, and I have O. On the left, I have 2 Ags, I have 1 C, and I have 3 O's. On the right, I have 1 Ag, I have 1 C, and I have 2 O's here and 2 O's here, so I have 4 O's, actually. Now, anytime you have something in 2 places, like the oxygens in 2 places and 2 different compounds on the same side, that's always something I recommend that you wait and balance that last, because it's hard to figure that out until you have everything else balanced out. If you try to do that one right away, usually you end up making mistakes, and then you have to go too far to do it. So I usually say, do that one last, and then whatever you end up left over is what would work. Okay, so we might start with the Ags. I have 2 Ags on the left. If I need 2 Ags on the right, that works. It didn't do much else for the C's and the O's. My C's are already balanced, so now I actually don't have any other choice but to try to balance the oxygens. So it may take a little bit of trial and error. Sometimes after you do a lot of them, you'll start to see patterns right away, but that takes a while to get familiar with those types of patterns. So I'm going to talk through how you probably would think it through if you were doing this, and then we can go back and look at it again. So in order to get, what I would think through is this. In order to get more oxygens on the left side, if I look at what I can do, I could potentially take 2 of this whole molecule, silver carbonate. If I do that, I put a 2 in the front. That then gives me 6 oxygens, right? 2 times 3. If I do that, that also gives me, it changes the amount of Ag and C also. So it then gives me 4 Ags, right? 2 times 2. And then it gives me 2 carbons as well. So now I have some other things that I have to do on the right side. So I'm going to leave the Ag because I can see that the Ag is single by itself. That's going to be really easy to manipulate at the end of all of this. I'm going to worry about the carbon first. So carbon, I need 2 of them over on the right. In order for me to get 2 of those, I need to have 2 carbon dioxide molecules to have 2 carbons over there. If I do that, then that's going to change, of course, my amount of oxygen that I have. I have now 2 times 2, which is 4, plus the other 2 from the O2, which that gives me 6. So now my 6 and my 6 are balanced. Now I can go back to the Ag. I had gone to 4 Ags on the left, so now I really am going to need 4 Ags on the right. I'm going to go back and erase that 2 coefficient that I had to start with because I need 4 of them, not just 2. So if I have 4 Ags, then I have 4 Ags on the right, I have 4 Ags on the left, 2 times 2. My carbons match, my oxygens match. If you want to, you can add a 1 in front of the O2. You don't have to, you can just leave it blank, and if you leave it blank, then that signifies that there's 1 of them. So either way is fine. So now that one is balanced. So for the other 3 problems here, if you look at them, if you kind of look at just looking through what you have here, you have zinc 1 oxide. So zinc 1 oxide is going to be something, right, that's pretty similar to what you did in number 3, because that's, again, a transition metal. You have the Roman numeral. It's decomposing into a metal, zinc, and then oxygen, which is always oxygen gas. That's just a rule of things. Like, always have those, oxygen gas. So this one is going to be pretty similar to number 3. If you look at number 5, you have calcium chlorate, calcium chloride, and oxygen. So again, calcium chlorate, we have a metal there. We don't have any prefixes, so that would be another ionic compound. Calcium chloride, very similar, but the ending is different. Calcium, a metal, chloride, a nonmetal, so another ionic compound, and again, no prefixes, and then you have oxygen again. And looking at number 6, I have tricarbon octahydride, so I have prefixes. And also, I have carbon and I have hydrogen, which are both nonmetals. So this is going to be one that would be a covalent compound, and I would use those prefixes to tell me what the formula would be. Reacts with oxygen gas, we've talked about that one. Water, you know what that is. Carbon dioxide we just did before, but again, you have a prefix, so you can use that to figure out what the formula would be of carbon dioxide. So that's how you would think through 4, 5, and 6, and then just go through the same process I showed you for balancing.